There are rare moments in the history of space exploration when reality seems to move beyond what scientists expected. Most of the time, the universe behaves according to rules we can measure, calculate, and test. But every once in a while, something appears that forces researchers to stop and question what they thought they understood. Voyager 1 has spent decades traveling farther from Earth than any other human-made spacecraft. Launched in 1977, it passed worlds that had never been explored up close before and eventually crossed beyond the protective bubble created by the Sun. For almost 50 years, this tiny spacecraft has continued sending information across an unimaginable distance. Its technology is ancient by modern standards. Its computers are incredibly limited compared with today's devices, and its available power decreases year after year. Yet Voyager continues operating far beyond the region where it was originally expected to survive. That alone is remarkable. But imagine receiving a signal from the same region of space that does not behave like ordinary interference. A signal with repeating structures. A signal with unusual timing. A signal that appears to change depending on Voyager's transmissions. That is where this story takes a dramatic turn. Before reaching interstellar space, Voyager had already encountered environments that completely changed our understanding of the solar system. Its journey began with Jupiter. The largest planet in our solar system is surrounded by enormous storms, intense radiation, powerful magnetic fields, and a collection of moons unlike anything seen on Earth. Voyager's observations revealed an environment far more active than many earlier models had suggested. On Io, volcanic activity was discovered on a scale never previously observed beyond Earth. Material was being blasted far above the Moon's surface and interacting with Jupiter's enormous magnetic environment. Jupiter itself displayed atmospheric storms larger than our planet. Its radiation belts were powerful enough to challenge spacecraft systems. The encounter demonstrated something important. Space was not a quiet, predictable place. It was dynamic, energetic, and capable of producing conditions far outside everyday human experience. Voyager then continued toward Saturn. Saturn represented the end of Voyager 1's major planetary encounters. Its spectacular rings revealed complex patterns caused by gravitational interactions. Titan, the planet's largest moon, possessed a thick atmosphere that concealed its surface from ordinary observation. After Saturn, Voyager's trajectory carried it away from the planets. The spacecraft was entering a completely different chapter of its existence. The Sun was becoming more distant. Its influence was gradually weakening. Communication delays were increasing. And the solar wind that dominates much of the space around the planets was becoming less powerful. Voyager was approaching the edge of the heliosphere. The heliosphere can be imagined as an enormous protective region surrounding the solar system. It is created by the continuous stream of particles flowing outward from the Sun. Scientists had spent decades developing models of this region. But until Voyager reached it, those models could not be tested directly by a spacecraft traveling through the boundary itself. What Voyager discovered was more complicated than a simple wall separating two regions. The outer edge of the heliosphere was dynamic. Particles behaved differently. Magnetic fields interacted in unexpected ways. Pressure and plasma conditions changed as Voyager moved farther from the Sun. Eventually, Voyager crossed into interstellar space. For the first time, a human-made spacecraft was directly measuring the environment beyond the Sun's protective influence. And the interstellar medium was anything but empty. There were charged particles. There were magnetic fields. There were waves moving through plasma. There were cosmic rays traveling enormous distances across the galaxy. The spacecraft had entered an environment that humans could only previously study from a distance. Voyager's instruments became our remote sensors in this unexplored region. One of the most interesting instruments aboard the spacecraft is its plasma wave system. Plasma waves are not sound waves like those traveling through Earth's atmosphere. However, their electrical signals can be converted into frequencies that humans can hear. This allows researchers to transform measurements from space into audio. The resulting sounds can be extremely strange. But it is important to understand that unusual space sounds do not automatically represent communication or intelligent activity. Natural plasma processes can create highly structured signals. And that distinction becomes extremely important when discussing claims about mysterious transmissions from Voyager. Over the years, researchers have observed unusual variations in the plasma environment around the spacecraft. Some of these changes can be connected to solar activity. Others are related to interactions between the heliosphere and the surrounding interstellar medium. The deeper Voyager travels, the more valuable these observations become. Voyager 1 was never designed to operate for this long. Voyager observed active features on Triton that suggested the Moon was not simply a frozen, inactive world. Instead, material was being expelled from its surface. The outer solar system was proving once again that nature could create environments far stranger than scientists had imagined. These discoveries changed how researchers thought about planets. Worlds did not need to resemble Earth to be scientifically interesting. Extreme pressure could produce unusual chemistry. Powerful magnetic fields could reshape surrounding particles. And temperatures, atmospheres, and internal structures could produce phenomena that had no obvious equivalent on our planet. Eventually, Voyager 2 also reached interstellar space. Now both spacecraft were traveling through the region beyond the heliosphere. For humanity, this represented a historic achievement. Two small probes launched in the 1970s had survived long enough to become our first direct explorers of interstellar space. But this is where the more mysterious version of the story begins. Various dramatic claims have circulated about unusual signals supposedly detected from the Voyager spacecraft. Some versions of the story describe organized pulses. Others claim that an unknown object responded to Voyager's transmissions. Some even suggest that the spacecraft detected an artificial structure or encountered an advanced civilization. These claims make for an extraordinary science fiction story. But they should not be confused with confirmed NASA discoveries. There is currently no established evidence that Voyager has received a deliberate extraterrestrial transmission, encountered an alien spacecraft, or communicated with an intelligent object. Nevertheless, the idea raises a fascinating question. What would happen if a spacecraft traveling between the stars really did encounter something artificial? Voyager carries a message from Earth. Each spacecraft contains a golden record designed as a symbolic introduction to humanity. The record contains carefully selected sounds, images, music, and greetings representing life and culture on Earth. The purpose was never to establish an active communication system. It was more like placing a time capsule into the ocean of space. A future civilization could theoretically find it and learn that Earth once existed. But imagine the opposite scenario. Imagine that Voyager detected something artificial first. The first clue might not look like a message. It could appear as a change in the surrounding magnetic field. It could be an unusual plasma disturbance. It could be a radio signal. Or it could be something that scientists initially classify as ordinary interference. That is why anomaly detection is so important. Researchers do not immediately label every strange measurement as evidence of extraterrestrial technology. They compare it with known physical processes. They check spacecraft systems. They examine solar activity. They compare observations from different instruments. They attempt to reproduce the effect. Only after conventional explanations have been exhausted would a genuinely unexplained signal become scientifically extraordinary. This process is slow. And that is exactly what makes real discoveries so valuable. A genuine unknown cannot simply be declared mysterious. It has to survive attempts to explain it. Now imagine that Voyager detected a signal that appeared to repeat with unusual precision. Scientists would first ask whether the signal originated inside the spacecraft. Could aging electronics create it? Could a damaged component generate the pattern? Could the spacecraft's communication system produce a harmonic that engineers had not noticed? Then they would examine Earth-based equipment. Could the Deep Space Network be introducing the effect? Could another spacecraft be responsible? Could terrestrial radio interference somehow be contaminating the measurement? After that, researchers would compare the signal with known astronomical sources. Pulsars produce extremely regular pulses. Stars can generate powerful bursts. Planets can interact with their surrounding plasma. Supernova remnants can produce enormous amounts of electromagnetic energy. Natural phenomena can sometimes appear remarkably organized. So a repeating signal would not automatically mean intelligence. But suppose every conventional explanation failed. Suppose the signal appeared only during Voyager's transmission windows. Suppose it changed when Voyager changed its communication pattern. And suppose the same behavior was observed independently by multiple instruments. That would be extraordinary. Scientists would still be cautious. They would collect more data. They would attempt to reproduce the effect. They would ask other observatories to observe the same region. Only repeated independent confirmation could turn an anomaly into a serious scientific discovery. This is what makes the idea of a mysterious Voyager signal so compelling. The spacecraft is already in a region of space that humans have barely explored. Its measurements are helping scientists understand the boundary between our solar system and interstellar space. Every piece of information matters. Even a tiny variation in plasma density can tell researchers something about the environment surrounding the